Very, very important announcement, guys. So I sent out an e-class announcement yesterday. If you haven't got a chance to check it, please check it. Your programming test number 1 and 2, I have postponed each one of them by 1 week. And the way to check it would be, you can go to the lecture site and go to the semester calendar, the PDF. It's been updated. Even if you check the syllabus, it has been updated as well. The grading scheme is exactly the same. I didn't modify the weights. It's really the same. It's just that for your programming test number 1, you can see now, it's now rather than, oh, I gotta refresh it. Okay, make sure you refresh your browser. There we go. Rather than the 6th of June, it's going to be the 13th of June. So next Monday, you will be, your lab number 1 will be due. And after that, I'm going to release the solution for lab number 1. So you do have enough time to really look at the solution and study for that. That's my intention. So you get a little bit more time to get prepared. Lab number 2 is not going to be covered in your programming test 1. However, it's going to be covered in subsequent tests, so don't delay. Okay, so definitely get started with lab number 1. And myself and the TA, we will be in the scheduled lab session tomorrow, Friday. There's no scheduled test tomorrow in the lab session, so just Q&A. Myself and the TA will be there. You can ask us any questions you like. All right, that's about the change on the test days. Please notice that. And then, so next week, I'm going to release the guide about the exact coverage about your programming test 1 and also some practice tests as well. And for the review session, we'll still hold one, but that one there, the survey got to be changed. I'll keep you posted. Your programming test 0, we are grading it, but it's going to take a little bit longer. But I will make sure it's actually returned back to you Monday, June 9th, the latest. Hopefully earlier. It's just sometime next week. And your priority should be make sure you got only 1 more week for lab number 1. So please make sure you get started and also finish that in time before you look at the solution. You got to make sure you can do it on your own. So that's why you got to struggle as much as possible before the submission deadline. That's the best strategy. And then we got 2 slides for you so far about classes and objects and exceptions. I'm going to mostly follow my iPad notes on the examples and also principles. But everything is also on the exceptions there. I mean, the slides is self-contained. You can definitely take a look. I don't need to read off the slides. That's not your best interest by coming to the class. All right, any questions? You mean the announcement about the test dates? Like this exact, yeah, this one here is part of the iPad notes. So if you go to the lecture site, you will see the iPad notes. Yeah. Yeah, so your fellow students' question was, how can you find this kind of announcement? Just go to a lecture site, and then you will see that, for example, under each lecture, for example, for last time, you can click on this one here, right? And that one there, you can see announcement right here. Right, okay. All right, guys, any other questions about the course? Question? So programming test 1 for the coverage, I'll confirm that, but I can tell you now, programming test 1 has no exceptions, no. But you will be on programming test 2, right? So you better study that, okay? But you do have time to study that. Alrighty, let's do a recap from last time and then we'll continue. So guys, please, I'm very sensitive to noise. Please, I really beg you for your consideration, okay? Also for your fellow students. Thank you. Okay, so last time we revisited this, oh, forgot to switch. There we go. That's my fault. Right, so last time we revisited this notion about caller versus callee. So please revisit this notation here. And we're going to use the caller callee when we talk about exceptions. Especially today, I'll give you even more visualization about how exceptions work in general. And also we're going to finish that to handle or not to handle example as well. We'll do that today. And then we talk about how you can trace a chain of method calls. You always got some entry point of execution, and then you might have some method call in the middle, in which case you have to suspend the current method execution and go to that method. It's like a step into. That's exactly what the Eclipse will do for you if you put a breakpoint around there in the method call. Right, so that's an example we did from scratch. For this course, you don't really need to know the mathematical property or implementation detail for what a stack is. But you have to know intuitively how you can use a stack to trace the execution of methods. So for exceptions, there's one case. And later on, in the last part of the course, we're going to learn about recursion. In that case, you also have to use a stack to trace the method call. So you want to make sure you understand the example here, and also you can read off the slides, self-contained, and then let me know if you got any questions. All right. And then, so that's really the page we spend the most time on Tuesday. So this one here basically just kind of tell you, okay, let me summarize very quickly, and then we got even more visualization for you today. This is the entry point of execution. And this method calls this method here, this method calls this method here, and this method calls this method here. And somehow this method here is where some exception is originated, which means some exception is thrown from here. From then on, we have to be subject to catch or specify requirements until this exception here is somehow handled or caught. So here's the principle. But now, from the method where this exception is originated, we don't typically handle that right away. Typically, we only specify it. And the way to see it is, I'll show you right away. So if you recall the example we did, you can see class A, and also we got method MA. This is where that exception is originated. But we didn't have any catch, try and catch block. We didn't handle that. So all we did was we simply say the method throws some exception. So from where the method is originated, usually you just opt for the specify option. That's just the convention. Okay? Number one. And number two, this method here is going to propagate the exception to its caller right here. And for all the subsequent caller, if they are subject to the catch or specify requirements, they got two options. They can either try to specify, so they will propagate further the exception, or they can choose to handle by having a try and catch block. So here we're assuming that this caller here is actually going to further specify. So it's going to throw that, he's going to propagate that exception further, okay, which we'll see a little bit later. Okay? And then for this caller over here, it is still subject to the catch or specify requirements. But this caller here is going to choose to handle that, meaning that this is the method where you're going to see the try and catch block. So the exception that's originated from here ultimately is going to be handled right here. And this is the point where we stop enforcing the catch or specify requirements, meaning that in this chain of method call, this main method here is no longer be subject to the catch or specify requirement. This is why for version 1 that we did last time, okay, I want to show to you right away. You can see A here, MA, and also we got the class B. Here you can see MB over here is where we try to handle this exception. That means up to this point, we stop the loop about enforcing the catch or specify requirements. The caller for MB, which is the tester. If you look at the tester right here, that one there calls the MB. But you can see here, we neither specify nor handles the exception. So this is the point where we don't really try to enforce the catch or specify requirements. So when you study for this lecture here, I want you to somehow think about that, what I just summarized in that diagram there, and look at version 1 to verify, right? Also, version 1 is what we go over in detail. Exception, there's no way around. You have to, number 1, know the principle. Number 2, look at the examples to see how the principle is instantiated. And number 3, maybe make up your own example just to see how the exception can be traced. You get lots of opportunities in lab number 2 once we release the lab. All right, any questions so far? Yeah?
Is there a reason as to why we don't catch, we specify in the
Okay, so here. So for this, yeah, okay, I know exactly what you want to ask. Okay. So in this particular example here, we just, for illustration purpose, we say, let's say, for example, this caller here chooses to specify. That's our assumption. It doesn't need to. In reality, if you are the implementer for the caller, you have a choice. Either you can choose to specify or you can choose to catch. It's completely up to you. Which way you want to go depends on what you need. But for this illustration here, we just say one caller chooses to specify, so that's why the exception will be propagated further to the next caller. But this caller here decides to handle the exception itself, in which case the enforcement about catch or specify requirements stop there. So that's why its caller here does not need to either catch or specify. Okay? Alrighty, let's now move on. All right, and then we talk about this particular setup, and we have done version 1. I'm going to show you version 2 and version 3 as well, just to see different possibilities. Okay? And this is the particular call chain. We got tester calls b.mb, which calls a.ma, right? That's what we have. I assume you guys are familiar with this particular call stack for now. All right, that's about for last time. So before I move on to version number 2, and maybe I'll move on to version number 2 in a moment. But let me talk about catch with specified requirements. So that will be the slides. Let me see here. Okay, it's on slide number 13. All right, 13 and 14. Let's go over this requirement very quickly again, and then we'll try to reinforce its understanding by using version 2 or version 3. All right, so you can try to somehow handle the exception either two-way, catch or specify, right? So catch means you're going to simply use a try and catch block. You're trying to handle that right away. And I'll get to it just in one moment. And also the second way is to specify it. Specify simply means I know the method I'm calling may throw some exception, but I don't want to handle that. I'm just going to declare myself, which myself also possibly throw that exception. Okay, let me show these two to you. So there are two options here. Okay, first of all, we want to understand this. This method call here potentially may throw some exception. May throw some exception. Also, this method call here potentially may also throw some exception. In both cases, if you're calling a method that might throw some exception, you will be subject to the catch with specified requirements. All right, so now we're going to see either we catch or specify. Okay, let's now again just revisit very quickly about caller callee. Right, usually the caller will be subject to the catch with specify. Okay, so you can think about this is the callee that might throw exception, and also this is a callee that might throw some exception. Let's clarify that. So now in the context of the main, in this case, it will be the caller. So the caller is now subject to the catch with specified requirements. The caller over here, and also the caller will be the withdraw method here, okay? Okay, so this will be the caller. Let's go with the catch option. The catch option goes like this. We have the try keyword, and also we got some catch block as well. So this is the catch option, meaning that we're going to handle this exception right here. This simply means handled the exception from callee right here. Such that this will not be propagated any further to subsequent caller. Such that caller of the main method here, if there's any caller of this method here, is no longer subject to the catch or specify requirements. Right? This is so important for you to see. Okay? Because we have handled the exception right here. On the other hand, the specify option simply means I don't want to take the responsibility. I simply declare I might also throw this exception. Right? I'm going to handle this. I'm going to let my caller handle that. Okay? So this one here is going to be here. You can see as part of the method here, we say throws. As part of the header, we specify the callee's exception might occur. And what that means is whichever method that's going to call me this withdraw, they have to handle that somehow. Okay? I'll write it down here. And the consequence is caller of bank dot withdraw is still subject to the catch or specify requirements. All right, so you really want to contrast about these two scenarios over here. In this case, if the caller chooses to handle the exception right here, it's not propagating any further. On the other hand, if the caller chooses to only specify this option, this exception here, that means its caller will still be subject to, and might be subject to, and so on, right? All right, any question about this? Okay. Yeah, so I would say today I should be able to cover most of the principles and many examples that should be representative enough for exception today. So over the weekend, it will be your best interest to really review the slides and also go over the recording if necessary to really get it clarified. Hopefully by the 1/3 of Tuesday, I should be able to finish everything, but just by going over even more example with you about tracing. Okay, so make use of the weekend, if you want to do some study about this course. All right, let's now move on. So that's catch was specified, and then okay, I do have some execution flow. Let me get to this one a little bit later. Let's now revisit version 1. Let me talk about version 1, 2, and 3, and then we'll summarize the rules. I think that might be better. Okay, so let's revisit what version 1 is about. Version 1 here tells us A.MA is really where the exception is originated, right? So let's just remember that, right? So A.MA is where the exception is thrown. A.MA, all right? And then A.MA, we actually choose it to specify, right? Throws, okay? So that's why you will see this arrow right here. That means A.MA chooses to specify. And then what about B.MB, which is a caller of A.MA? If you go to B.MB, you can see that we try to handle that, right? Remember, catch was specified, right? We see that right away. So this is where we choose to handle the exception right away. We don't want to propagate it any further. Okay? So this is caller of A.MA chooses to handle or catch the exception. That means the caller of B.MB is no longer subject to. No longer subject to the catch or specify requirement. Okay, let me just verify this again with you. So you can see that over here, because we already tried to handle that already, so this exception is no longer going to be propagated, right? If you look at tester, you can see the tester is trying to call B.MB. But here you can see there is no specify. There is no throws. And also there is no try and catch around it. So neither. Why? Because it's not subject to the catch or specify requirements anymore. So it will still compile. Right? So that's a critical point. You guys will have to make sure you understand. Okay? That's version number 1. And then we're going to try to change maybe a little bit about how the callee going to behave, and things might change slightly accordingly, according to the principle. So I do have some little question here. Let's answer that very quickly. B.MB, okay, it is still subject to catch was specified, right? Yes, it is subject to. And it chooses to, B.MB actually chooses to handle or catch. And also we talk about tester.main. Over here, it's no longer subject to, right? Because it's callee B.MB already handled that. You only need to handle the exception once and for all. Okay. No, because it's callee B.MB already handled or caught the exception. All right. That's version 1. Let's now take a look at version 2. Okay? Before I try to program version 2, let's see visually what I want to change. It's going to be very similar to version 1, mostly. But except, you can see the call stack right here, right? A.MA is where the exceptions originated. It will choose to specify. And then B.MB, rather than handling, it will also choose to specify. That means now this method here is subject to catch or specify. And then this one here has option. It can either choose to specify or catch. Let's say it chooses to catch right here. Let's say. All right? That's kind of the outline. Let's now move on to here. Okay? I'll show you how you can create this. So we already got version number 1 here from last time. I can simply just copy and paste. Control, or we can simply say edit, and then copy, right? And then right click on the source folder, and then you can say paste. Okay, I'm going to call that version 2. Okay, so it's going to be a duplicate to begin with. And then let me close everything from version 1 just to avoid confusion. Okay, so now version 2, I start with exactly like version 1. But let me go to, so A here is where the exceptions originated. I don't want to touch it. Okay. And B here used to be in the version number 1, used to handle the exception. Let's say I don't really want to handle at this level. I want to propagate this exception to its caller, let's say. So what I can do is simple. B.MB cos NA, and say B.MB chooses to specify. Right? That's all I got to change. Specify or propagate the exception. Propagate. Okay, and then I'm just going to remove this and remove that. If you only have this, you still kind of get back to the compilation error because at the moment we neither specify nor handle. But we want to specify. What do? Specify as part of the header. Throws negative value exception. And that's going to be from version 2. All right? Right, now everything compiles right here. Okay? So as far as B.MB is concerned, we choose this to specify. What does that mean? That means now the negative value exception is going to be propagated to tester, the main. So if you go to the tester, now tester wouldn't really compile from version 1. Because tester here, you can see we are calling B.MB, which throws that negative value exception. So now we are subject to catch will specify, right? What should we do? Let's say we want to do catch. Okay, so we can say try and catch. And for the catch, you will specify the exception you're expecting to catch. So negative value exception. Okay, from there, I'm just going to call this. Right? So what I can say here is, you can see say the following. So tester.main calls B.MB, which might throw negative value exception. Now, tester.main has 2 options, is subject to the catch or specify requirements. And say that tester.main chooses to specify, catch, beg your pardon. Because we do have try and catch block here. All right, like that. And let's do one thing here. If I do the catch over here, catch simply means, I'll talk a little bit more about execution flow in one moment on the iPad. But for now, let's understand this. This one is telling you, when I try to execute this method call, if the negative value exception really occur, for example, if I give you the value, let's say -5, for example, right? This one should really trigger that exception. If that's the case, then we are going to go to the catch block and execute whatever that's inside the catch block. Okay, I'll make it a little bit more precise a little bit later. But for now, I can simply say system, for example, the out print line. You want to print something to the console if you want to. So we can say something like negative value exception occurred. Okay, something like that. So -5 over here is somehow ultimately going to trigger because 5 minus 5 less than 0 is actually true, meaning that we're going to throw that exception, right? Let me do this one time just for you guys so you will have some idea. I will highly recommend try to use the breakpoint debugger when you study for this example here and try to see different scenario, how things are going to be executed, right? I'm going to show it to you just once. If I go to the test domain, let's put a breakpoint right here, line number 12, right before I make the method call, all right? And I'll launch the debugger. So I'm going to pause over there. Okay, and I will switch to debug perspective. Okay, bear with me. It's going to pause line number 12. There we go. All right, so we're pausing right here, right? So let's do two passes. Pass number 1, I'm just going to say step over. Okay. Oh, let me do one more thing. I think that can make it even more explicit for you. Let's say this. System.out.println. Okay, so somehow you can say after the method call that might throw negative value exception. Okay, I'm going to launch the debugger again, and I'll pause and give you guys some hints about how to think about this one here. There's a logical thing going on here, which we have to understand. All right, guys, let's now take a look at here. Okay, I'll give you some guidance. I want you to focus on line number 12, 13, and 16. All right? Line number 12, we are trying to call a method, which may or may not throw the negative value exception. If the argument value there is less than 0, it's going to throw that exception. If it's greater than 0, then it's not going to throw that exception, right? So may or may not. If that's may or may not, that means you might either go to line number 13 or you might go to line number 16, either way. So that's kind of the execution flow we have to study a little bit further in a moment. But for now, let's get some intuition, right? In this case, if I say step over, would I go to line number 13 or 16? Okay, that's something we're going to see, okay? So if I simply say step over, I go to 16. If I go to 16, that means somehow line number 13 was skipped. It was not executed. So I went directly to 16 because the negative value exception was thrown. Okay, scenario number 1. And scenario number 2. What if I give plus 5? This way here is not going to trigger the exception. All right? If I try that one there, and then I'm going to launch the breakpoint again, launch the debugger. Now, if I say step over, am I still going to line number 16? That's the question. It turns out no, because in this case, we are not going to trigger that exception. Okay, let me do one more. If I say step over, we go to line number 13, right? So that will be something I also need to summarize to you a little bit more generally after this example. But you want to really practice about these two scenarios. When you are trying to call any line, like a line number 12, that line may or may not throw some exception. You really got to think about there are two possible paths that might happen in the execution. Either the exception occur, in which case line number 13 will be completely skipped, and you will go to line number 16 inside the catch block, scenario number 1. Scenario number 2, if the exception did not occur, that means you will just normally go from line number 12 to line number 13, just continue with the normal execution flow. All right? One more thing I want to show to you, one more thing. How do we see exactly where the exception might occur? Let me change this back to -5. Well, that'll be a second pass, right? I'm going to go into, again, launch the debugger right here. Okay. Now, rather than saying step over, we know if I say step over, it's going to go to line number 16. But I want to see exactly how. Let's now say step into. If I say step into, it's going to go to the method MB to see how exactly MB is executed, right? So if I say step into, so now I'm now in MB. And if I say step over, MB is going to create a MA, and now MA is where the exception may be thrown. Let's step into once more. If I say step into once more, I'm now in MA, right? Right here. So this is where the exception may or may not be thrown, depending on what the I value is. You can see if I move your cursor over, I value is right now -5, as I just passed. So -5 less than 0 is going to be true. So if I say step over right here, it's going to throw it. So this is the very place where the exception got thrown. And everything else happens afterwards. All right? And if you say step over again, it's actually going to go to the catch block, right? Because we're going to catch that exception. And we never got a chance to really print this line because exception already occurred. All right? That would be something I would really encourage you to keep trying yourself to really make sense out of it. On the written test, you will be given something slightly more complicated, but I'll give you some practice. We'll also do some practice as well in the class. To figure out exactly the execution flow when you got some possible exception that might be thrown is a very important learning outcome for this course. Okay? So that's version 1. Okay? And the breakpoint debugger, I will leave the exercise to you. But if you got any trouble using it, let me know. And let me go back to the Java perspective. So that's version 2. Okay. Let's now recap about version 2 quickly. Okay. Okay, so version 2 is right here. Okay. So version 2. So this is where So this is where the exception was originated, the same. And then in this example here we say specify. And also, its caller also try to specify. That means we propagated the same exception twice, right? And then when we get to this test domain, we choose to catch. Okay, so this is where we try to catch, right? You can see at each level we actually got catch was specified. And then let's answer the question very quickly. Beta MB, apparently it is subject to, right? Yes. Yes, and it chooses to specify. And similarly, for test domain, over here, it is subject to it, but somehow it chooses to catch. Right? We'll see this try and catch block. Yes, and it chooses to catch. Right? You can definitely compare the same two questions there, but for different versions, you might have different answer. Right? That's why I kind of put the same question there for you to double check. It's more like a study question. Final version, which you should never do. All right? The final is, well, the final version will be, let's say none of the callers, including test domain, wants to handle that exception. What does that mean? That means everybody simply specify that exception and expect the external user to be seen, to actually see that exception. Right? Let's see exactly how to reproduce this. All right, let's now go back to Eclipse here. All right, let me close everything about version 2, and then I'm just going to copy that, right? So again, you can go to Edit, Copy. And then right-click on the source, and then you can say Paste right here. Let me call that version number 3 right here. All right, let's now do some modification. Pretty simple. So for version number 3, we still keep A the same. That's where the exception got thrown. And also for class B, also the same. That one doesn't choose to catch it, just specify it. And when we go to the tester, that's the final caller, kind of at the bottom of the stack. That one there, let's say rather than catching it, you will try to specify it, which syntactically is possible. Okay? You will compile. So let's say we get rid of this, like that. Okay? When I first got rid of this, it will be compilation error because neither specify nor catch. But as soon as I do the following, you can see between these two braces, I'm going to say throws. I'll make it bigger. I'm going to say throws negative value exception, right, from version 3. Now everything compiled because now even in the last caller at the bottom of the stack, I choose to specify. Chooses to specify. So now there's no try and catch at all. What's going to happen? If I try to say run, well, exception is going to be thrown back to us on the console. This is something you as an implementer should never do. You should make sure the exception that might occur at the runtime should somehow be handled at some point in the call stack. At which point should it be handled is up to your design. But in the lab number 2 that you're going to practice the exception, there will be hints in the JUnit test cases to tell you where the exception should go. Right? All right, any question? Yes?
So when let's say you're in a method, right?
Yep.
And you choose to specify, but then that method has multiple exceptions. How will you write the sentence?
Sure. Sure. Your fellow student question goes like this. I will just sketch a little bit. I think that's something that will be covered a little bit later. Oh, you know what? I'll just put it here. That one there goes like this, right? Let's say I'm in some method here. I'm now in some method here. Let's say method M again. And then here, let's say I'm trying to call different methods. Assuming that I already got a context object created, let's say. I might got object number 1, the method number 1. And then object number 2, the method number 2. Object number 3, dot, method number 3, etc. And let's say these callees may throw different exception. Assume that, let's say, O1.N1 may throw. Let's say my exception 1, okay, doesn't matter. So my exception 1, okay, and this one here may throw. My exception 2, and this one here may throw. My exception 3. Apparently, this method call here is subject to catch was specified. So you got 2 possibilities. This one here is also subject to catch was specified. You got 2 possibilities. And this one here, you also got 2 possibilities. So in reality, you got 8 different possibilities. You can say, for example, specify, specify, specify. Or I can say specify, specify, catch, and etc. Right? Exactly which combination you want to use is up to you. But let me show you one extreme, which your fellow student was kind of asking. What if I want to simply specify all of them? Let's say that's one possibility. What I can do is I can insert right here, right? I can say throws. And then I can say my exception 1, comma, my exception 2, comma, my exception 3. So this one is corresponding to this. This one corresponding to this. This one satisfies the catch was specified requirement for this, right? Yes. Can I answer your question? Good.
And if it is catch, so if it's already thrown the exception, how will you write the catch?
So if you, for example, let's say if for this one here, rather than specify you want to catch it, right? You just say try and catch and put this one inside a try block, like what we did.
Okay.
Yep. Okay. All right, let's now continue. We should take a short break very soon, but why don't I just recap very quickly about version 3. All right. So you can see for version 3, again, this is where the exception was originated, and then we choose to specify here, choose to specify here, and choose to specify here as well. So it's all specified 3 times. So here, B.MB definitely is subject to catch was specified. This one here also, right? So both of them, yes. Yes, and then you choose to specify it. And also this one, yes, you also choose to specify it. But version number 3 is a bad example about what you should do. You should never try to throw the exception back to the user. At least you should handle that at some point. Doesn't matter which point. All right, so we got all the 3 versions done. Okay. I would suggest we take a very short break by taking attendance. After the break, I'm going to somehow talk a little bit more about execution flow and generalize how exception handling can happen. Okay. Let's now take a short break by taking attendance, please. So before the break, we finished that example where we got 3 versions about where to really specify or catch the exception. So I think now it's now time for us to pause and try to generalize certain rules and go a little bit deeper into execution flow. And guys, the most important exercise you really want to do on Eclipse is to really see how you can put a breakpoint debugger and see how the execution flow will change. I will give you a little bit more idea as we try to summarize the rule. All right, let's now take a look at some example here. Okay, the first one. Okay, so we talk about flow over here. And I'll give you two scenarios. The two scenarios will be, scenario number one, let's say we do have the context of some try and catch block. Okay, we got some try and catch block over here, try and catch block here. And the second scenario will be, we just got the method itself, the caller, specify the exception, right? We got two different scenarios for you to consider. Let's talk about each one of them. And then to see how the execution flow is going to go. And when I say execution flow, that means you have to be used to labeling the steps of execution, starting from one all the way to the last step until the program terminates. That's something we're going to do. Okay? Okay, so let's see the first one. So we do have the try and catch block. Let's say the following. In general, this is a try and catch block we have right here, and then there might be some code that comes before that, and there might be some code that comes after that, right? So we got all these different combinations, all right? And you want to think about when we try to execute the code, what's really going to happen, okay? And let's now identify the method call of our interest. Let's say this one here. O.m right here, and also O.m right here. So let's say the method m may or may not throw some exception, right? May throw some exception, and also may throw some exception. So there is more like a binary choice. Either it happened or it does not happen, right? Let's talk about two different scenarios. Let's say the first scenario is where the exception does not occur, beg your pardon. Does not occur, that means the input seems to be fine. There's no exception thrown. Okay? So let's say here, what we're going to assume is, for this method call over here, no exception occur. Let's say. With that assumption in mind, let's see how the execution flow is going to go. Right? And before the try and catch block, of course, that one has to be executed first. So that'll be number one. And then we'll reach the try and catch block. And the first line in the try and catch block, we're going to execute this method call right here. And that particular method call, let's say the exception does not occur. If it does not occur, we say that we got normal flow of execution. You just go one line after the other. After this, we're going to go to line number 3 over here. That means the associated catch block is not going to be executed at all. So this one here is completely bypassed. So think about this one here is bypassed because the exception that it is supposed to catch did not occur. Bypassed because the some exception did not occur. All right, right here. And notice that we also got some line after the catch block. So they are kind of outside the catch block, so they should still be executed, right? So it'll be number 4 here. So the normal flow of execution is going to contain number 1, number 2, number 3, and number 4. Basically, anything that goes before the try block, anything that involves the method call, and also after that should also be executed. And also, you completely bypass the associated catch block. Anything that's outside the catch block, it should still be executed, right? That's a flow. Okay. This is normal flow. Normal flow simply means the exception did not occur and it didn't go to the catch block. Let's say a different scenario. We are still making the same method call, but somehow the input value here, for example, -5, is going to trigger the exception to occur, right? So this is where the exception might occur, let's say. We're making that assumption. So what I have is, let's say right here, let's say the exception occurred. Let's see what the execution flow will be like. It will be different, but some parts will be common to the normal as well. We still got to execute everything that's before the try block because exception, I mean the method call, has not happened just yet. And then we still have to execute this method call right here. But now, at this point here, we assume that the exception actually occur. That means we're going to go directly to the catch block that catches that. Go directly to it. And this is the part where the normal flow of execution got disrupted. Let me write it down first. So this part over here tells you that the execution flow got disrupted. Execution flow disrupted. If it got disrupted, that means the rest of the try block simply got bypassed. That's a very important part, right? And then we simply go to the cache, and then we're going to say number 3 right here. Right? Execute whatever that's in the catch block, and then outside the catch block, it will still be executed unconditionally. Right? So now if you compare this one here, it's going to be basically 1, 2, 3, and 4. Right? So the critical difference is in the normal one, this one here is executed, but this one is not. In the abnormal one, this one is not executed, but this one it is. Other parts are the same. Right? So get this idea straight first. And then as you actually try to play with more examples there, either in your lab or maybe some example you can create on your own, you want to somehow see how the execution flow can change, depending on whether the method you're calling really trigger that exception. Right? Any question about this? Right? So that's a scenario where we got some like a method call within the try and catch block. Let's see something very similar. Okay? Let's say we don't have the try and catch block. Let's say we are now within the context of a caller that might throw some exception. That's a specified option. Right? Just remind you very quickly. Right? So this is a specified option, right? And also this is also the specified option here. And the line of method call we are interested is here. O.M. O.M. And this may or may not throw some exception. Let's say some exception right here. May or may not. And it's a binary possibility, right? So let's say possibility number 1, let's say the exception, some exception did not occur. So for this one here, let's say some exception did not occur. And the other scenario is where it did occur. Some exception occurred. All right. And let's now see the execution flow. Okay. In some way, this might be a little bit easier for you to see because we don't have any try and catch block to kind of follow. But we still need to know, right? So let's say for this one here, this is a caller. That's more like an entry point of execution. So number 1, so there might be some one line of code, another line, and then object creation right here, and then the method call. So now, where should we go? Should we go to the next line, or should we just be interrupted? Since the exception did not occur, go to the next line. Number 5, number 6. Easy, okay? Simple. 1, 2, 3, 4, 5, 6. Okay? This is the case where exception does not occur. And what about where the exception does occur? Up until the point that we try to call the method, it will be the same. So we have 1, 2, 3, and 4. Up to this point here, you can see 1, 2, 3, 4, 1, 2, 3, 4, they're the same. But let's say this point here, the exception got thrown. What does that mean? That means you got to think, let's try to visualize what's happening here. We talk about C.M1, right? So think about C dot M1 is actually on top of the call stack. And here we are actually trying to call O dot M. Let me just use another one. O dot M is going to be added to the stack because it's another method call, right? That's how we did the tracing. Now O dot M throws an exception. In that way, this exception here is actually going to be propagated to C dot M1. C dot M1 also choose to specify it. That means it's going to propagate that exception further to its caller. Agree? Okay? That's how you should understand how things are going to go. So that means C dot M1 is actually going to propagate some exception to its caller at the runtime. Okay? So this is really where you should really think about. Okay? Right here. And the rest, right here, will just be bypassed because we don't really get to execute it. It got disrupted. Okay, so for this part here, let me just say a little bit more, just to give you a little bit more guidance. So here, the rest of C1.N1 got bypassed because the flow got disrupted. Right, so when you study this example here, I think the right-hand side one is actually very important, especially you want to be able to link what's really happening here with what we spoke about last time, right? Because when the exception actually occurs, it's going to be propagated to the current caller right here. And the caller here chooses to specify, that means it's also going to propagate it further to its caller, and so on. Okay? Now think about these two scenarios, especially the last one I just spoke about. Okay? All right, any questions? Okay, so let's now do something a little bit more abstract. This one here is going to summarize about what we have said so far. A little bit symbolic, but that's really the best way to really see what's going on. All right, let's go step by step over here. So here I'm basically saying I have a call stack, a chain of method call. At the bottom there, this will be the entry point of execution. Okay, let's start from the beginning. So this will be the entry point of execution. And we're talking about a call chain of, you can see 1 here, 2 here, 3 here, all the way to n. We got a call chain of n methods, right? So let's see this. So we got right here a call chain of n methods. And for simplicity, I simply say the first method here is from class 1, second method here from class 2, and the last method here is from n. And we have to use some indices here, I plus 1, just from I plus 1, right, etc. So the method index just the same as class index, just make it systematic. But we'll get n methods in total in the call stack. Let's say we're trying to make this kind of method call, starting from here, and this one calls this one calls that, this one calls that, etc. Finally, this will be the last call here. Let's say this is where we got the exception thrown. So this will be the origin of exception. So this will be the origin of the exception. So origin of exception will be C1.M1. All right. And if you kind of recall the example that we did in the Eclipse, right? We kind of said that in the worst case, after the exception has been thrown, it might just be propagated from all the levels until here, which also chooses to specify, like a tester.main. That's kind of extreme case. Remember? Okay. So let's now make it a little bit more general. Let's say at some point, one caller decides to handle the exception at some point. Okay? So let's say this is the point. Ci.mi. Let's say we assume. Okay? And all our reasoning is going to go based on this assumption. So we have the assumption that Ci.mi is the first caller choosing to handle, to catch or handle the exception. The exception. Guys, it's a very important assumption, all right? It's the first caller. Around the middle. Of course, I here, in general, I could be n, or I could be 2, for example, right? Different cases. But I'm just saying I. So now we're going to answer the following question. Given that this will be the first method that's actually going to handle the exception, what does that mean? That means all the previous callees, they choose to specify. Right? All these chooses to specify. All these callees choose to specify. This is more like a lemma or whatever, right? Because if I say this is the first one handles that, that means all the previous one chooses to specify. That's why when the exception got propagated to here, now I say I want to handle it. Okay? Now, let's answer these two questions. Given that we know this, and given that we know this, what are the exact methods that are subject to catch or specify requirements? How many? Give me a number. In this kind of setup, how many methods in total were subject to the catch or specify option? Meaning that for that method there, it chooses to either catch or specify. How many exactly? I. Okay? I? Okay? Yes. All right? It's exactly here. Okay? All right? Right here. This one here, this one here, this one here, all the way to here. All these methods were subject to catch or specify, but specifically, all these choose to specify. The last one here choose to catch. All right? So these are subject to catch or specify requirements. Okay, let's write it down first. It's going to be C1.M1 all the way to Ci-1.n minus 1 and also Ci.mi. Because you can see that here are the ones specified. And the very last one, which is going to end or terminates the enforcement of catch or specify requirements enforcement. Okay, this one will be the catch or handle. Now, question number 3, very important. How many methods are there which are free from the catch or specify requirements? N minus I, exactly, because if these are the ones subject to it, of course, the rest will be not subject to it, right? But visually, you should know how to distinguish between them, all right? So this one here, I'm just going to put it here, right? So from here, all the way to here, okay? So these are the methods not subject to. Catch or specify requirements. Okay, so it will be from Ci I plus 1 dot m I plus 1 all the way to Cn dot mn. Okay? N minus I methods. Okay? All right? Are we okay with this? All right? Let's try to give you a little bit more insights. Let's talk about two extreme cases. Extreme case number 1. Typically, we said for the very first method where the exception got originated, that's not where we do any catch. Let's keep that assumption. Okay? So when will be the earliest point we can handle the exception? Earliest point. Right here. All right? So earliest point will be, so here we simply say method is actually handled. Handled or caught in C2.M2. That means this is the only one that's actually specified. And this is the one that catches that. And the rest of the stack is not subject to the catch with specified requirements anymore. All right? That's the extreme case number 1. All right? That implies C3.M3 and onwards, not subject to catch or specify requirements. All right? Okay, the implication over here is actually very important, the consequence. All right, extreme case number 2. Where will be the latest point that we handle that before the exception got thrown to the external user? The bottom of the stack, right? The lowest one, really. Okay, that one I can answer for you. And for that one there, it would be Cn dot nn. So that means we are only going to handle this right here. This will be the handle. That means all the previous ones over here will just be specified. Okay? So that one, this one will be catches or handles the exception. That means all the methods on the stack are subject to the requirements. Catch or specify requirement, right? And of course, in reality, it could be anywhere between these two extreme cases, right? So I think at this page here, very symbolic, I can see, but it really nicely kind of make it very precise about how things are going to happen. So that's the exact rules about exception handling in any OOP. All right? Guys, any questions about this? Good? Okay, think about it. It's being recorded, so you can rewatch it if necessary. Okay? So really focus on where will be the first one that will handle the exception. Any points lower is not going to be subject to catch with specified requirements anymore. Handle and catch, we kind of use them interchangeably. So catch is really like a syntax we write in Java. So I just say catch the exception. But people also say when you say you catch an exception, you're basically trying to handle that exception in the catch block. So both are valid. The same thing, yeah. Catch is more to do with the Java syntax. Handle is more like a layman's term, right? Okay, so let's now move on. Okay, I want to do a little bit code tracing with you guys very quickly. Okay, let's do that. Okay, we got about 11 minutes-ish. Okay, let's now do, hopefully we can do 2. Okay, let's see. Let's do the simple one first. Let's say we have some exception class that we create, right? We know how to create an exception in Java, in Eclipse. Let's say it's called invalid radius exception. Let's say we want to calculate the area. Yes, we want to calculate the area of a circle based on its radius. Okay, so that's the exception class we create. And then let's say we got a circle class, And then we also, let's see, okay, yeah, sorry. We got a circle class here, and also we got circle calculator 1. Okay, we got two classes over here. All right, so let's say here. So we can see that we got set radius right here. This is one method here. And also we got the set radius being called right here, right? And then it's called in the context of circle calculator 1 main method. So now you can work out exactly who the caller is and who the callee is, right? Okay. I don't think we need this. Let me just delete that. Okay. So the caller would just be the circle calculator 1 dot main. And the callee would be the circle dot set radius. Set radius, right? So this is the caller, and this is the callee, right? Simple. And let's do a little bit of tracing. I think this example here I just want to show to you how different situation, one situation where the exception is thrown, the other one is not thrown. How is it going to work? We got two cases over here to trace. And just before that, let me just show you the call stack very quickly. So we start with circle calculator 1 dot main, entry point of execution. And then we got a callee, which will be circle dot set radius, right? Just to keep that in mind. Okay. Let's try two different cases. Okay. Just for clarity, I'm just going to erase this for now. Oh, sorry. Okay. There we go. All right, the first input I want to try will be 10. That's the first input, which presumably shouldn't trigger any exception, right? If I try 10 right here, I want to see what's going to be the flow of execution. So let's now try to label exactly. So guys, take maybe just about 30 seconds to think about if I pass 10 as a value over there, what's going to be the flow of execution? How do you label 1, 2, 3, 4, and etc.? At the same time, you can think about what if I pass a different input value, -5? Is the execution flow going to change, right? Yeah, think about that, and then we'll go over the answer. Let's go over this one first. All right, so let's say I pass 10. I'm going to start from the line number 1 here, right before the try block, right? Number 1. And then create a circle object in number 2. I'm going to try to set the radius for 10. So here, I'm going to branch out to that method call, right? So set radius is here. So that means number 3 will be here. And then number 4, oh, I beg your pardon. That's my mistake. We're calling set radius here, which will be right here, okay? So we should really go for number 3, right here, line number 1 for that method, right? At this point, R is 10. 10 less than 0 is false. So we don't really execute the if branch. Instead, we'll go to the else branch to set the radius to be 10. And then after else part, we are basically done with executing set radius. So now we're going to resume from here, right? And then number 5 is going to be right after the set radius. Number 5, number 6. Okay. Are we good with it? Okay. And of course, here, when I say number 4 here, I really meant it's going to execute this line here. If you got further line, you may have to use different labels, right? But for now, it's simple enough. All right, so for this part here, also, we don't really have any exception thrown. So catch block over here is completely bypassed. And let's use the same block of code right here. And we're going to execute a second pass. And we're going to use the value -5 right here. Okay, I'm going to use a different color. -5, right? Right here. Let's see how things are going to go. I still have to create a circle, line number 1, before the try block. I will set a radius now, rather than 10, I'm going to set it to be -5. Okay, So it's going to be number 2 over here. And then I'm going to step into set radius, which is going to be 3 right here. It's going to be 3 right here. So that means r is going to be minus 5. Minus 5 less than 0, true. Meaning that I'm actually going to execute this one here to throw the exception. So that'll be number 4. And I will simply bypass the else part. Right? And then once I throw the exception, now, guys, what will be number 5? Where should number 5 be? Number 4 is about when I throw the exception. What will be the next step for execution? Catch. Very good. Thank you. Because the rest over here for the set radius will just be bypassed, right? Notice one thing here. I was executing this line here that throw the exception. So bypassed, right? So if I go to the catch block, so now you can think about it. It depends on how we count. You can definitely count the catch block itself as a line. So we can say number 5 will be the catch, and number 6 will be this particular printout. Okay, just print out the exception objects, right? 1 to 6. Yeah.
I'll go for the green one for 10. When you went to number 5, C dot get area, wouldn't line 6 be the get area?
Oh, I see what you mean. Yes, I definitely agree with you. Thank you so much. Your fellow student was exactly right. Number 5 here is going to call this get area here. So which means I'm going to go to the get area, which would be number 6. And then after I calculate it, it's going to return. And then I'm going to go for number 7 here. Thank you. Absolutely. All right, let's see something slightly more complicated, slightly. And this one here could be a very nice case study for you guys about using like a Boolean variable. Okay, I'll get to the point here. And then we can do some tracing quickly. Okay. So here, what you guys want to pay attention to is what I highlighted here. I got some Boolean variable. It's called input radius valid. Basically, I want to allow the user to enter into the by the keyboard some radius. If the user enter -5, it's invalid, so I'm not going to accept it. But I'll allow them to enter another value, maybe -10, which is also invalid. I'll keep allowing them to enter value until they give me some non-negative value. That's kind of the fault tolerance I would like to implement. Okay? So I just got this variable here, initially false. I haven't read anything from the user that's actually valid. And then I got some while loop. While loop tells me that, okay, negation here, I'm going to see exactly how that works. This one tells me as long as what the user entered on the keyboard is not valid, which could be -5, -10, -20, etc. Right? And then I'm also going to try to create a circle object over here. And this is a very interesting way of using try and catch block, right? So here I'm saying that I'll try to set a radius to be r. And the r here is read from the keyboard, which could be -5 or could be 10, etc. Depending on what the execution flow is. If I'm able to go from here to here, that means the exception did not occur. That means the input is valid. In that case, I can simply set this one to be valid, which is true. And when I go back to the while, it's not true, it's going to be false. So I will exit from the loop. On the other hand, if I actually try to execute this line here, and that one there does throw some exception to me. In that way, I'm actually going to go to the catch block, and then this Boolean value remains to be false. Okay? That's kind of overall picture. Okay? So what I want you guys to try over the weekend is to try the following. Let's say we want to have the following interaction with the user. They first enter -5, and then they enter 10. What's going to happen? And then we'll go over this as well in the beginning of maybe Tuesday, just to show to you the execution flow. All right, we'll end the class a little bit earlier today. All right, thank you so much.